And this recording is for Algebra 1, Chapter 4, Lesson 3. No quote today, sorry guys. We have a lot to talk about. All right, function rules, tables, graphs, and then some. Okay, so a function rule is an equation that describes a function, an equation where there is one y to each x, because remember our definition of functions from the last lesson. Remember, you can only have one y for each x. Okay, so an input-output machine is basically what you can think of as a function rule. An input goes in, it does some math, and an output comes out. So for our input-output over here on the right in this chart, a 1 goes in, it gets multiplied by 3, which is 3, plus 4 gives me 7, which is my output. The same for 2 goes in, we get a 10 out, a 3 goes in, and we get a 13 out. So you can think of it kind of like a machine, but if that confuses you, don't worry about it. It's just an equation. You stick a letter in for x or whatever your input is, or excuse me, you stick a number in for whatever your x is, and you get a y out, which is your output. Okay. All right. So functions. A function is a function. A function is in function notation when it is has an f parentheses x to indicate the output, and we read that as f of x, or f is a function of x. So instead of using y, you can use f of x, and sometimes they use like g of x, h of x, t of c, p of c. You'll see a p of c later in this lesson. So it changes. So if as long as it's got like a letter, parentheses, and then another letter, and then that second letter is what's actually inside the equation, it's in function notation. And normally we can write things as f of x is equal to 2x plus 1, and then the domain is x. Now that's x. And actually that's something from the previous slide that I don't know if I mentioned. Okay, no I did. So x is the input, y is the output. So the domain, remember from the last one, is x, whereas the range is y. So if they want us to evaluate the function rule, they kind of want us to figure out what the range is based on the domain given. In this case, the domain is -3, 1, and 4, so we're going to do this 3 times. Once where x is -3, once where x is 1, and once where x is 4. So I already did the math for 3, so there you go, f of -3, where f of x was 2x plus 1. I'm replacing x with -3, and I did the math. So therefore, f of -3 is -8. So then if I do f of 1 is equal to 4, and f of 4 is equal to 13. Therefore, the ranges are -8, 4, and 13 when the domain was that, and this was my function rule. Okay? So yeah, you're probably going to have to do a few math problems more times than you want with different numbers, but yeah, such is math. Okay, so you guys can try that one on your own. I'm not going to waste any time on it because I've got tons more to talk about. Okay. So, tables identify specific inputs and output values. So we know it's a function, obviously. If it's a straight line, we talked about that in the last lesson. Parabolas, matters which direction they're going. Circles, no. So you do need to make sure that you're looking at how things work and you're really understanding that is there only one y to each x value? Is there only one range to each domain? Is there only one dependent variable for every independent variable? Because yes, we have more vocabulary. An independent variable is basically the input, and we graph those on the x-axis. Always. This is something you should know from science as well. As the dependent variable is the output values, and that's graphed on the y-axis. So if this should also look familiar from last lesson, if my independent variable or my x value is -2, my output variable is going to be -3, okay? Because that's the point, -2, -3, okay? And then I can move a little further up, and I can say, well, if I'm here, my x value is 1, and my y value is 2. Okay, and knowing this information obviously then can help us write a function rule, because you guys should be familiar with like slope, right? I should be having some flashbacks from last year, even though we haven't talked about slope yet, but you'll see how they're all related in a bit. Okay, so that's the graph. All right, and so yeah, the independent variable graphed on the x, the dependent variable graphed on the y, and then pointing plots obviously can show the function. Okay. All right, so we can figure out these points, obviously, by using a function rule to come up with coordinates. Coordinates that we can plot, coordinates that we can then connect with the dot and see the function in action, or see the relationship in relationship in action. So if I have the function rule, f of x is equal to 3x plus 4, I'm actually not going to use -4 as one of my inputs. I'm going to use -2, but I'll change that in a second. I'm going to plug in my points, and you get to see all my mistakes. There we go. So there we go. So 2, if I plug in 2, it's actually supposed to be -2, not +2. -2 in for x, I'm going to end up with my point where x was -2, because I got that from there. And then when I do the math, I'm going to get -2. Okay, because -2 times 3 is 6, -6, -6 plus 4 is -2. All right, and then I'm going to use 0 for x as one of my inputs. 3 times 0 is 0, plus 4 is 4, so I end up with the point 0, 4. Again, x is 0 because that's where I started out, and the answer to this is 4, so that's how I got that. And then the same with 2. So that should give me the point 2, 10. Now, for my graph, I'm using intervals of 2. So each line is, so that would be 2, 4, that would be 2, 4. This would be -2, -4, -2, -4. Okay, so that when I graph it, I have the point -2, -2, 0, 4, and 10, 2, 10, and you guys can see that it's a straight line. Okay. And again, this is a function because it passes not only the vertical line test, but every value of y has its own value of x. Okay, and it goes on forever. Duh. Okay, so when graphing, especially for real-world situations, use appropriate intervals and units. If they're only positive integers, only use quadrant 1. So in this example, suppose your group recorded an album. Now you want to copy and sell it as a CD. One company charges $250 for making a master CD and designing the art for the cover. There's also a cost of $3 to burn each CD. The total cost is P of C. So remember how I told you it doesn't have to be f of x. It doesn't even have to have an x in it. You just know that P is basically the output where whatever C is would be the input. So P of C depends on the number of CDs C burned. So use the function rule. P of C is equal to 250 plus 3C to make a table, to make a table for the values and graph. Well, I'm not even going to graph it. I'm just going to talk to you about it. Now, am I ever going to be in the negative money range? Hopefully not. Normally we don't graph negative money because normally that means you're in debt. Now, in the real world, it does happen, so it might be beneficial to know when you're in debt. But for this particular case, we're hopefully not going to be in debt. Hold on. Sorry about that. Coach Al interrupted me. But okay. And then the other thing that needs to be positive is the number of CDs. We're not going to order negative CDs. And since since the CDs is the input, it is also the independent variable, which means it gets graphed on the x-axis. So if this is the number of CDs we're buying, and P is the price, basically how much it's going to cost your group to do it, we're always going to be in the positive region. You know, I'm never going to order negative CDs. So it's always going to be positive number CDs, which means if it's a positive number of CDs, my price is always going to be positive. So whenever you're graphing these sort of things, you want to keep it in the quadrant 1. And you need to be aware of when it's appropriate to be in quadrant 1 or when it would be appropriate to be any of the other quadrants, really. Okay, and we'll talk about that more in class, of when it's appropriate, when it's not, and what should be where and whatnot. Okay, so just another quick example of graphing. I just want to show you an absolute value problem. Whenever you have absolute value, it's going to graph as a V. But it's always going to be a V going up because you usually don't have a V going down unless there's something going on outside the absolute value that results in a negative answer. So if you plug in -4, 0, and 2, you're going to get points of -4, 3, 0, -1, and 2, 1. And it's basically going to look like those points, and then you're going to connect them, and you're going to notice a V. If you did more inputs, you're going to get a more defined V, and this is normally what happens when you have when you have absolute value in a problem. You're going to get a kind of a really nice V shape going on. All right, so when you have an exponent, very important, you're usually going to get a U shape, or at least when you have something to the power of 2. When you get into the powers of 3 and 4, you're going to get crazy stuff going on. But for the power of 2, you're going to get something called a parabola. And so if you plug in those numbers, you're going to get these coordinate points, and when you graph them, you're going to get kind of a U shape. So more of the U shape. It's already come back to haunt us now 2 lessons in a row. Okay, I'm going to keep going because this is already not as long as I thought it was going to be, which is a good thing. So this is the last slide. Identifying functions, and we are definitely going to talk about more of this in class because it's very important that you understand domain and range. And actually, I forgot to put something in there. There we go. Okay, so when you have kind of just a straight equation that just has our 4 basic operations, multiplication, division, subtraction, and addition, all of these are usually, not always, because I'll have to show you one with a division in just a minute, they're defined for all real numbers, so that if you stick a real number in, you're going to get a real number out, and it's going to be a unique situation. Each number you put in is going to produce another number, an output that is unique. This is when you're going to have the function is set the way it is, okay? It's going to be a function. The relation is a function. Now when you get into some of this crazy stuff down here for number 2, we have y equals 1 divided by 3 plus x. Well, there are certain times when the domain, no matter what you put in for the domain, you're going to get a funky output, okay? And really, there's a possibility where what you put in for x is going to give you something that doesn't work mathematically. So if I stick in a -3 for x, I'm going to get 0. Dividing by 0 is not, well, it's cool in math, but we call it undefined. So therefore, x can actually not equal 3 in this situation. So the domain works for all real numbers except for -3, because if I stick -3 in there, I'm going to be dividing by 0, and we can't have that because basically an output has to be defined, and it would be undefined if we divided by 0. So for the domain for number 2, it cannot be 0. All right, but every other answer that we would stick in, every other input we're going to stick in is going to give us a unique output. So therefore, it is a function as long as x is not -3. Actually, it's supposed to be negative. There we go, -3. Cannot be -3. Okay, so for the last one, we have an exponent. That's what the little caret means, by the way. So that's really y to the 2nd power. Okay, so if x equals y to the 2nd power, it's always going to be positive or 0, because a negative times a negative is positive, a positive times a positive is positive. So no matter what, your output is going to be positive by the virtue that we're putting it to the 2nd power every time. So the value of if the y value cannot be assigned 2 possible solutions, therefore it cannot be a function. All right, so this particular number 3 is not a function, okay? And we're going to talk about how you can define domains and ranges for these different situations in class tomorrow. So definitely be ready to ask some questions, and definitely be ready to answer some questions. All right, I'm done. See y'all later.